Okay, so last class we talked about discrete and continuous random variables in general. We took a look at the table that had a distribution. We calculated the expected value or the mean. We calculated the standard deviation. What we're going to do today, I think if I remember correctly, we touched on a little bit at the beginning of the year, and so it might be familiar, but it is transforming and combining random variables. So if we have two random variables, putting them together, what is the mean, standard deviation? That kind of idea. There are no new formulas today. There are just some ideas. So if you find this page, please. We're going to be taking a look at some similar data. And yeah, we'll go from there. El Dorado Community College considers a student to be full-time if he or she is taking between 12 and 18 units. The number of units X that a randomly selected El Dorado Community College full-time student is taking in the fall semester has the following distribution. So number of units between 12 and 18 and the associated probabilities. Draw a probability histogram, then calculate and interpret the mean and standard deviation of X. What I would like you to do is do that right now with the person next to you using your calculator. Do not construct a histogram by hand. Have your calculator do it for you. So right now, put all of those units in list 1. Put all of those probabilities in list 2. I'll do the same thing up here just so you can see what you should be getting. So move your desk with the person next to you, please, or turn to them and get working on that, please. Did we all get the histogram? Yes? I'm not going to copy it down. You should have, though. Like I said, just the general histogram. When you found the mean, hopefully you got it to be about 14.65 units. Did we? And did we ask ourselves, does that make sense? An average of 14.65? Yes, it does. And then the standard deviation you should have gotten is about 2.056 units. Did we? Okay, so if we were to interpret something along the lines of, in the long run, if we selected many full-time students from El Dorado Community College, the average number of units taken would be 14.65. Sound good? Were we specific, or would we be specific in saying full-time students from El Dorado Community College, because that's considered the context? Oh, guys, I feel like I'm just by myself this morning. Why are we so quiet?
I don't know. This is a lot. This is a lot to look at everything at once.
I need you guys to perk up a little bit, okay? Whew. We're going to do one more question, and then we'll take a break. This seems like a multiple break kind of day. I'm going to show you something else on the calculator, so I need you to stick with me. Okay, moving on. At El Dorado Community College, the tuition for a full-time student is $50 per unit. So if T equals the tuition charge for a randomly selected full-time student, then T is equal to 50x. Right? So if you're taking 13 units, we multiply that 13 by the $50 to get how much you're paying. So there's the probability distribution for T. My question 1, how did they get these numbers?
They multiplied the units X from up top by 50.
Okay, great. So what I'm hoping we notice is all they did was take these numbers, multiply by 50 to get the numbers in the bottom table. But do you see that the probabilities are the same? Okay, so we're going to calculate the mean and standard deviation. We're also going to look at the histogram. We need to be efficient, though. Do you guys really want to go put all of those numbers in again? I'm going to show you how to do it efficiently, so follow me what I'm about to do up here. Okay, did you get the exact same graph? You should have gotten the exact same graph, did we? Okay, I didn't actually calculate it, but what did you get as the mean? $732.50. Standard deviation, again, I didn't calculate. What did you get?
102.8.
You guys agree? Okay, so the question is, did we actually have to do all of that work? Did we have to put that back in the calculator? If you notice, if we take our answer from the beginning and we multiply by 50, that's how we get the new mean. If we took the standard deviation and we multiplied by 50, that's how we get the new standard deviation. So what does that tell us? If we multiply or divide by a constant, by a number, that will affect the mean and the standard deviation. Does it affect the shape though? No, it looks exactly the same. Okay, so how do we put that into words? If we multiply or divide by a number, here's what happens. The shape stays the same. The center, so what I mean by that is the mean, the median, anything like that, is also multiplied or divided by that number. And then the spread, in our case, standard deviation, is also multiplied or divided by that number. So if we multiply by a constant, it affects the center, it affects the spread. Does not affect the shape. Questions on that? Let's keep going and let's talk more about El Dorado Community College. I'm excited also. In addition to tuition charges, each full-time student is assessed student fees of $100 per semester. C is the overall cost for a randomly selected student. And so then you notice this is our new formula. So we're taking whatever the tuition is and adding the $100 fee. So if we take this table from above, add 100, we get now the overall cost. What I want you to do right now on your calculator, put these numbers in. You can do the same thing I did before. List 1 plus 100. Put that back in list 1. Calculate the mean and the standard deviation, please. If you want to look at a histogram, fine. Really what I care about most is the mean and standard deviation. Okay, I believe you got a mean of $832.50 and that the standard deviation stayed the same. You agree? That should make sense because what is happening is you're taking a histogram and you're just shifting the histogram by 100. So obviously it's going to affect the mean or the center, but the spread doesn't change. All we did was shift. We okay with that? Okay. So writing that down on the next page, what is the effect of adding or subtracting a constant? So if we add or subtract a number, the shape is unaffected. The center, we add or subtract that number. So we added 100, which means our mean was affected by 100. And then the spread is unaffected. This is the idea of a transformation. So a transformation is taking one variable, adding or subtracting a constant, multiplying or dividing a constant to make a new variable. So in our case, on the first page, we took x. And then when we did t is equal to 50x, that's an example of a transformation. When we did c is equal to 100 add t, that's a transformation. All you need to know is what we already found. When we multiply by a constant, it affects the mean and standard deviation. When we add a constant, it affects the mean, it does not affect the standard deviation. Okay, so let's take a look at this example. In a large intro stats class, the distribution of raw scores on a test was approximately normally distributed with a mean of 17.2 and a standard deviation of 3.8. The professor decides to scale the scores by multiplying the raw scores by 4 and adding 10. A, define the random variable y to be the scaled score of a randomly selected student from this class. Find the mean and standard deviation of y. Okay, First thing you have to do is write a formula. Please do not just throw numbers in without having a formula or a rule. So in our case, y, the scaled scores, it says multiply the raw scores by 4. So that is 4x, and then we add 10. If we want the mean of y, multiplying by 4 affects the average, adding 10 affects the average. So all we do is we take the mean of x, which is 17.2, we multiply it by 4, and we add 10. I have no idea what that is. Can somebody do that, please? Thank you. Standard deviation of y, this is the one where you have to put a little more thought in. Standard deviation of y, if we multiply by 4, is that going to affect spread? Yeah. If we add 10, is that going to affect spread? No. So 4 will expand the spread, 10 just moves the distribution. So for the standard deviation, we can ignore the 10. We just take the 4 and multiply by the standard deviation of 3.8. Again, can somebody please do that for me?
15.2.
Thank you. 15.2.
When are you supposed to use that symbol versus like an S?
S comes from a sample, where sigma comes from the population. So sometimes it's not clear. I'm assuming that this professor has the data from all the students. Okay, what is the probability that a randomly selected student has a scaled test score of greater than 90? I want you right now to do part B perfectly. So, what kind of distribution is this? Show the work that you need to show. Make sure you come up with the correct answer. It's a normal distribution, so show all of the normal stuff. Take 3 minutes, please. Okay, here's what I got, 0.231. There are 2 things that College Board is going to be looking for. It's pretty likely that you will have a question with the normal distribution. So I'm going to show you the minimum to get full credit. You have to, at a minimum, show the cutoff and the value 90. So if you want to put that in probability notation, you can. The other way to do that is on the figure to have 90 and to shade above it. One of those 2 will get you full credit. If you have the shading but you don't have the 90, you're not going to get credit. If you have the 90 but you don't have the shading, you're not going to get credit. If you have this but the wrong symbol, you're not going to get credit. So if your symbol is not right, don't write it. Just do the figure. And then the other thing that you need to somehow communicate is that it is a normal distribution with a mean and a standard deviation. So if you write that line out, you're going to get credit. The other way is to draw the figure and have both sets of labels. So I have you do double work. But for College Board, if you write that line, you'll get credit, or the graph, you'll get credit.
Would we need to write out the mean and standard deviation if it's like on the side? Like for part A?
Repeat your question? I don't know if I understand what you're
Like,
asking.
so because in part A we explicitly stated the mean and
Probably no. No. So the question is, we wrote the mean and standard deviation here. Do we really have to write it again? Probably not. We're going to do one more question and then we'll take a break. Do I have your attention for one more question? Okay, suppose that the height of male speed daters follows a normal distribution with a mean of 68.5 and a standard deviation of 4. And the height of female speed daters follows a normal distribution with a mean of 64 and a standard deviation of 3. What is the probability that a randomly selected male speed dater is taller than a randomly selected female speed dater he is paired with? Okay, start everything in probability notation. So m, it already gives us the variable. We know that m is normal. I'm going to do mu of m because we're given 2 means. So just to be clear, that is 68.5. The standard deviation of m is 4. So then F is also normal. The mean of F is 64. Standard deviation of F is 3. And then in probability notation, what are we asked for? We are asked the probability that a randomly selected male will be taller than the female. So always start with everything that you are given. Okay, here is the trickiest part, is knowing what to do now. We are not going to say m is greater than and just put some number in for f. We're not just going to put some number in for m. Instead, what we're going to do is we are going to move everything to the same side. So if I subtract f, really I'm looking for the probability that m subtract f is greater than 0. Okay, the reason I do that is this is a new variable. Here's what I know about that variable. If m is normal and f is normal, when I combine them, regardless if I'm adding or subtracting, the distribution will still be normal. So if I take two distributions and combine them, I'm still going to get a normal distribution. So this is called a combination. Taking two variables and combining them into one. To find the mean of that new distribution, we just subtract 68.5, subtract 64. So that'll be 4.5. And then the standard deviation. Okay, this is the one that is very counterintuitive. We cannot just say 4 subtract 3, rather. And here's why. If we did f minus m, and we did 3 minus 4, we would get -1. Standard deviation can't be negative. Also, if we take two variables and combine them into one, spread should not get smaller. So you are never going to take two variables, put them together, and get a smaller spread. So it would not make sense to start with 4 and 3, but then end up with 1. So what you do for spread is it's kind of like Pythagorean theorem. You are going to take your two spreads, you're going to square them and add them, and take a square root. So even though it is m subtract f, we still add.
That is essentially the Pythagorean theorem.
Yes, it is.
Or essentially just find c.
Yep. Now, this is just a normal distribution problem. Now we would just go to the calculator. We're going to do normal CDF. So do this now, especially because I don't have the answer. We're looking for 0 and everything above it. So it's going to be 0, some big number. Standard deviation is mean rather is 4.5. Standard deviation is 5. So please do that. And I think you get about 0.816.
Where is the normal? How do we get the normal CDF again?
Second distribution. Now, ask yourself, does that make sense? Does it make sense that about 82% of the time the male will be taller than the female? Yes.
What?
Okay, last page. We have 2 examples to do. This first one, in my opinion, is the hardest example. Suppose that a certain variety of apples have weights that are normally distributed with a mean of 9 and a standard deviation of 1.5. If bags of apples are filled by randomly selecting 12 apples, what is the probability that the sum of the 12 apples is less than 100 ounces? Okay, to start us off with, we know that apples are normally distributed, and the mean of those apples is 9, and the standard deviation is 1.5. I think you guys will know what to do once you have a rule or a formula. what a lot of people do is if we're looking for the sum of the 12 bags, so I'm going to let T be the sum. T is the total. What a lot of people do is they say, well, I have 12 apples, so it's 12 times A. Does that accurately reflect how we would measure the sum of this bag of apples?
No.
What is this communicating?
But it implies that each apple is the same.
It implies that you measure one apple multiplied by 12. Is that going to give us the sum accurately?
But no, it's going to give us the product.
Okay.
The sum is from addition.
Okay. So we need to consider that each of those apples likely has a different weight. These are not the same. These are not the same, and they're not the same because of the spread. So let's talk. If we were going to find the mean of both, in the first one, the mean of T, actually, I'm going to make this an S so we don't get confused. So can you guys just change that to an S? So the mean of, in this case, we would do 12 times 9, so we would get 108. If we want the mean of S, we would just add up the means, right? So 9, add 9. Well, if we add 9 12 times, we're still going to get 108. So both of those formulas are going to give us the same mean. They are not going to give us the same standard deviation, though. So on the top one, if I wanted to find the standard deviation of T, multiplying by 12 affects spread. So I would just take that 1.5 and multiply by 12. And that would give me 18. On the other hand, for S, this is like the previous example. The previous example, M minus F, I told you you're basically doing Pythagorean theorem. You're doing the same thing here. So we're taking the standard deviation, squaring it for each of those apples, and then taking the square root. So if you want to write that a little more efficiently, there are 9 of that 1.5 squareds. Which ends up being about 5.2. So you see the formula makes a big difference. We have to recognize that we're adding the individual apples, not just multiplying by 12. And now it's a regular normal distribution question. So now you would use this information to find the probability that the sum is less than 100, which if you care, it ends up being about 0.0620. Questions, comments? Last thing you are doing is this last example. It should take you a whopping probably 2 minutes. All you're doing is finding a mean and a standard deviation and a shape. Please do this with the person next to you. This is what I got. So we already drew the histogram for C. Whatever the initial shape was, it's just going to be the same. And then the mean, add the two means. Standard deviation, we can't add standard deviation, so square them, right? Do Pythagorean theorem, and then take a square root. Again, remember though, the first example we did M subtract F. That even if you are subtracting here, so even if it's C subtract B, you're still going to add your standard deviation. Write this down. This is really important. Okay, big deal. I have seen this come up only one time, but it did come up. The only time you can do this is only if your two variables are independent. Like I said, I've only seen that asked on the AP test once, but I did see it asked. If we do not know that the variables are independent, you could not calculate the standard deviation. So you can only do that Pythagorean theorem type formula if your two variables are independent.